This is Science with Armstrong, and today we're going to take a look at statistics. In AP Biology, statistics is fairly important. It's something that we utilize to analyze our data from some of the experiments that we're going to be doing. First, let's just take a minute to review mean, median, and mode. So mean is going to be the average, and we often represent mean as x bar. You're going to have an equation sheet that's available to you to utilize during the AP exam. It is a double-sided formula sheet. This is the front side. This is the back. Mean, median, mode is all defined on here for you, but let's just go over it real quick so that way we have a quick reminder. So mean is often represented by x bar. So if we have some data points, let's pretend these are grades from a past test or past tests, 95, a 50, a 75, and an 88. So what we're going to do to find the mean is we're going to add all of those together, and with that we get 308. And then we're going to divide by the number of values there are. So there are 4 values, so we're going to divide that by 4. And that answer comes out to be 77. So the mean for these 4 data points is going to be a 77. The median is the middle number. So you need to put these in order. You need to find the middle 2 numbers and then divide by 2. So if we put the numbers in order, we have 50, 75, 88, and then 95. So the middle 2 numbers are going to be 75 and 88. So we're going to add together the 75 plus the 88 and divide by 2. So when we do that, it's going to give us an 81.5. So 81.5 is going to be the median for this set of data points. The last thing we're going to take a look at is mode. The mode is how often a number occurs. So let's take a look at another set of data points. So if I have 95, 50, 75, 88, 96, 50, 75, and 70. We'll put that in the front here. So if those are my data points, those are all the tests that I've taken over the course of this year. I'm going to look to see which number happens the most frequent. That is going to be 75 because it has 2 occurrences here. So 75 is going to be the mode. So next, let's take a look at standard deviation. Again, standard deviation is going to be on your equation sheet. It is something that you don't necessarily have to know how to calculate, but it is something that you should understand. We are going to do a few practice problems just so we can get an understanding of how it is calculated and we can get a better understanding for what standard deviation does. So here is the equation sheet. Here is standard deviation on the equation sheet. And again, you can see the star that is next to the standard deviation, and it just basically means you need to understand standard deviation, but you don't need to be able to calculate it. Standard deviation is going to be the measurement of how far away the data is from the mean. It's going to look at how spread out the data is. So let's take a look at a quick graph. This is a standard curve, meaning that here is the mean, or x bar, and then we have quite a bit of data that falls right near that mean, and then as we move further away from the mean, the less data points that we have. We can take a look at standard deviation and we can see how far away some of this data is. So on a standard curve, one standard deviation from the mean, so this is going to be -1, this is going to be +1, there's 34% of the data is going to be here, and 34% of the data is going to fall 1 standard deviation above. So adding these two together, 68% of your data is going to be between 1 standard deviation of the mean. So 1 above and 1 below. So 34% above the mean, 34% below the mean. Then, if we look at 2 standard deviations of the mean, so negative 2 below and 2 above, This is going to be 13% approximately. There is a little bit more exact numbers, but for our purposes, we are okay just looking at the 13 and the 13. You're adding 26% to the 68. So that's going to be approximately 94 to 95% of your data is going to be within 2 standard deviations of the mean. And then the 3 standard deviations from the mean, here and here, you're going to have 3 below and 3 above. There is 2.1 that fall in these areas. So when we add that, it's going to essentially make it 99% of our data should be within 3 standard deviations of the mean. And then this is going to be 0.1%. So that's just the leftover. That's basically the above 99%. So we can look at how far and close together our data is from this mean. So the higher our standard deviation, the more spread out our data is going to be. The lower the standard deviation, the closer our data is going to be. So let's take a look at another graph. So if we have this as one of our curves, and then comparatively, we have this as one of our curves, this curve here is going to have a lower standard deviation. And the first curve I drew is going to have a higher standard deviation. Because when we look at the mean on the orange curve, the data is more closely packed together, where on the pink curve, it's a little bit more spread out. So the higher the standard deviation, the more spread out the data. The lower the standard deviation, the closer that data is. So basically what you can look at is this lower standard deviation, you're going to have more consistent data. So things are going to be more consistent in size, shape, whatever you're measuring, whatever that dependent variable is. Whereas a higher standard deviation, you're going to have a little bit more variability in what your population looks like. So with your lower standard deviation, it's more likely that your independent variable is the thing that's changing or influencing your dependent variable, the thing that you're measuring. Where in a higher standard deviation, there's more of a chance that something else is playing a role. The last thing we need to talk about is standard error. This one you're probably going to run into a lot more in the fact that we utilize this when doing graphing. Standard error and standard error bars have been common on the last few years of the AP Bio exam. So understanding your standard error, how to read your error bars, is going to be very important for your success on the exam. Standard error is how well the mean estimates the true population. If the true mean is known, where you have counted every single individual, then it is a measure of accuracy. When you don't know the true mean, where you haven't counted every individual or every data point in that population, it's going to give you a measure of precision. Again, here is the equation sheet. Here is where standard error is located, represented by this, where it's standard error of the mean, is going to equal your standard deviation divided by the square root of n, or the number in your population. Is if we have our graph with our data points, we're going to use our standard error, and we're going to create a little bar that extends above and below that mean. So the mean is going to be this part of the bar there. And then you're going to go, if this was the example, you'd do 3.1 below. So this bar is going to be minus 3.1 from that, or 3.14 from that mean. And this part of the bar is going to be plus 3.14 from the mean. Now what's important is how we analyze our data. So what you would do is you graph out all your data points, adding in the standard error for each one of those bars. And what we want to look at is standard error bar overlap. That's going to determine if our data is going to be considered significant or not. So let's take a look at a graph example. where we have standard error bars, and we're just going to ignore units right now just so you can get a picture of what you need to look at when you're looking at standard error bars. So if these are the representative standard error bars, we can look that this data is statistically significant, meaning that whatever this bar is here, that bar is in fact statistically higher than this bar here, whatever it was measuring. Now let's take a look at a different example with different error bars. So I'm just going to draw another graph down below here. Again, with the same approximate bars. Again, I have no units. This is just for the sake of demonstration. And looking at this, whatever it is, we would probably assume that this bar here is higher than whatever this is here. So we could say this has more, there's more effect on whatever this is. This had a bigger change. This is taller. But if our error bars overlap, such as this, there is no statistical significance between these two data, or between these two bars. So we can't say with confidence that this bar is in fact bigger, taller, whatever, more, whatever it is, than this one, because our overlap of error bars. So this error bar overlaps that other error bar. So we can't say with any confidence this one makes any difference. And that is how you read standard error bars. Again, this is going to be extremely important. This has been on the exam in several different ways in the past 5 years or so. So getting to know standard error, how to read your standard error bars, and always make sure, always make sure that if you are drawing a graph, that you're going to add in the error bars. That's going to be an easy point to get by adding in the error bars correctly. And remember, you take the standard error, whatever that is, and you go up that amount and then down that amount. Don't make the bar the total standard error amount. It's up that amount and down that amount. Thank you for watching. This is Science with Armstrong.